Hello, ladies and gentlemen. I've had a couple people ask me about the homework already, so I thought I'd do a quick video just to clarify things a little bit. So what we have here is the first question on page 74 is asking you to calculate the derivative of a function, and they're going to change the function for each part, A, B, C, and D, and they want the derivative of the function at a value of A, and they're also going to change the A value as they go along. But for the first one they give you f of x is going to equal x squared, and for the first one they tell you that x is going to equal A. So this is really your x value here. So don't get too hung up on the notation. We could have easily replaced this with, use a different color. This could have been f prime of 1, okay? And that would have been f prime of x when x equals 1. So what you're finding is the derivative of the function f when x equals 1. And as we know, that has a geometric significance. That's going to be the slope of the tangent to f of x at that point. So let's take a look at what we have here. We're going to start off with two different ways to do this. We're going to do method 1, and I'm going to mimic what I did in the notes. Method 1 is going to take advantage of the fact that we know that we want the slope of the tangent at x equals 1. So we're going to find the derivative, or the slope of the tangent, at that point only. It's going to be some easier algebra, but it doesn't give us as much information as we could have if we found it in general using method 2. But they both have their place. So for the derivative, we need to remember that it has a definition. It is the limit as h approaches 0 of f of x plus h minus f of x over h. That is the formula. We don't forget that. We need to know that. So for this particular example, f of x is actually going to be f of 1. Because remember, in this particular example, they told us that a equals 1, and that's our x value. And they also told us that f of x in general is x squared. So that's going to be 1 squared is 1. F of x plus h for this particular example will be 1 plus h. So again, we're using the fact that we know that a is equal to 1, and so what that will be is 1 plus h squared, because it's the 1 plus h that goes into the function x squared. All right, so coming back here, what we'll have is the limit as h approaches 0 of f of 1 plus h minus f of 1 over h. Now I want you to be able to read this. This whole thing is the derivative. And the fact that I'm putting in a value here and here tells me it's the derivative at a particular x value. This is the derivative at x equals 1. So it is the slope of the tangent at x equals 1 is what I'm setting up. Knowing that f of x is x squared, we can go farther. It's going to be the limit as h approaches 0 of 1 plus h squared minus 1 squared over h. Now what we can see is we can see what f of x was. F of x must have been x squared. We can see it here, and the 1 plus h squared, that's showing us what f of x is. Moving forward with this, it's the limit as h approaches 0 of 1 plus 2h plus h squared minus 1 over h. Moving forward, that'll be the limit as h approaches 0 of 2h plus h squared over h. I'm running out of room, so I think what I'll do is I'll bring it up here. Limit as h approaches 0 of h plus, oh no, that should have been a 2 plus h over h. These will reduce. Start up the limit. Ring da 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 ding ding, ring da 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 ding. You have h approaching 0. This is approaching 0, and we get a final answer of 2. Now let's be very clear on what we found. We have found, I'm going to get a new piece of paper, we have found f prime of 1 equals 2. This means for f of x equaling x squared, the slope of the tangent when x equals 1 is equal to 2. A graphical representation. Here's y equals x squared. At x equals 1, grab a ruler. We have found the slope of the tangent at that point. Okay? And that's using method 1. And we found one slope of the tangent, and that's all I've got, but that's all the question asked for. So, let's compare that to method 2. Method 2, remember, we're going to have f of x was given to us as x squared, and they're telling us that a equaling 1. Well, and remember, I'm just replacing that for x because they used the variable a in their question when they asked for the derivative of f of a. Okay? So, what we're going to do now is I'm going to use method 2. And in this case, I'm not going to use the fact that we know the point where we want the derivative. Instead, I'm going to find a new function. I'm going to find what's called the derivative function. Of f of x that will give me the slope of the tangent at any x value. So I'm going to be getting a function here. And what I'll have to do at the very end is then sub in x equals 1. And that'll give me the particular slope of the tangent that I'm after. But in the first part, I'm going to find the derivative in general. So starting off, the derivative is given by the limit as h approaches 0 of f of x plus h minus f of x over h. That's a formula. In this particular example, I'm going to keep everything in general. So there's the biggest difference, guys. I didn't put in 1 here. I'm not using that. I'm keeping it as x. So this would expand out. Now when I go to put these values back in here, they're going to now give me the limit as h approaches 0 of x plus h squared minus x squared over h. Limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared over h. Limit as h approaches 0 of 2xh plus h squared over h. Limit, you can't see what I'm doing, sorry, h approaches 0 of h, 2x plus h over h. This and this will reduce as h approaches 0, ring-da-da-ding, that goes to 0, and we come up with a function 2x. Now let's be very clear of what we found. We know that the derivative function for f of x equals x squared is 2x. What that means, ladies and gentlemen, if we go back to our geometric concept of what's going on, we have f of x, which is x squared, and I have a new function that will give me the slope of the tangent if I put in 1, if I put in 2, if I put in 3. All of these slopes of the tangents will be calculated using this function. So this function gives me all of those slopes of the tangent. The slope of the tangent when x equals 1 will be 2 times 1, which is 2, which is what we found before. But I have the additional ability to find the slope of the tangent when x equals 2, which in this case will be 2 times 2. That'll be 4. So the slope of the tangent of that line is 4. Or I can come over here and find the slope of the tangent at x equals -3. So the derivative at -3 is going to be 2 times -3, -6. So the derivative of this line is the slope of the tangent, not the derivative of that line, I'm sorry, need to be careful of that. The derivative at x equals -3 of f of x equals x squared is this slope of the tangent when x equals -3 is -6. So in other words, we go over 1 and down 6. And that's the difference between method 1 and method 2. All right, I'm going to stop there.